Okay, in this screencast, I'm going to go over, I'm going to focus primarily on the different types of bonds, but this is the list of objectives that you have for the chemistry section of the anatomy class. So we're going to do characteristics, location, this stuff. We're going to do this in class with a case study. It's also in your book. These terms are in your book. Identify the chemical symbols. Those are in your book. Ion, cation, and anion I'll talk a little bit about as we do this. I'm not going to talk about this decomposition and synthesis reaction, so you need to look those up and read them in your book. And like I said, I'm going to go over types of bonds. You're going to need to know this because it's going to relate to a case study we're going to do, probably do over the use of Gatorade. All right, so let's talk about the different types of bonds. Give me a second here. Okay, so an ionic bond, covalent bond, polar and nonpolar, and hydrogen bonds. So when we talked about the atomic number, the mass number of different molecules, or so I should say atoms or elements on the periodic table, one of the things you have to understand is that on the periodic table, the atom is neutral. The amount of protons and the amount of electrons they have are the same. So there is no charge. Okay, there's no charge to them. So as you look at them on the periodic table, they are neutral, but they're not necessarily happy. And this is some basic chemistry. If you don't know this, you can just kind of ignore it. But if you remember from your chemistry class, atoms want to be happy. And to be happy, the last orbital of electrons has to be full. Okay, the last orbital has to be full. If they're not full, then they will either share with other atoms or they will give up or take electrons from other atoms. So off the periodic table, they're going to be happy and their last orbital is going to be full. So an ion is one where it's either taken an electron or it's given up an electron. And if it does that, it has a charge. So ions are charged atoms. If it gives up an electron, then it's positive, and that would be a cation. And the reason it's positive is because it has one more proton than electron because it just gave up an electron. If it takes an electron from another atom, then it has a negative charge, and that is an anion. The way I remember the difference between cation and anion, and this may or may not work for you, is that I like cats, so cats are positive. So a cation has a positive charge and anion has a negative. So when it jumps off the periodic table, if the last orbital is not full, it's going to do something in order to make itself happy. So if we have two anions, let's say we're at a party and there's the sodium, okay, which has a positive charge, Na+, and there's a chloride which has a negative charge, Cl-. These ions are going to be attracted to each other because the positive and negative are attracted to each other. When those two get together, then that is an ionic bond. So to be happy, some atoms will gain or lose electrons. I went over this, called ions, and then we'll have a charge. If they have a charge and it's an opposite charge, they will be attracted to each other. So what we've done is we've taken ions, and when they get close to each other, they're attracted to each other, and they have now become a salt, sodium chloride. So an ionic bond is when a positive and negative ion is attracted to each other. Now this is not a very strong bond. The example I use is it's a dating bond. So they've met at this party and they really like each other because they're different charges and opposites attract. But they're not committed. It's not like the next day they're going to get married. Hopefully, because we don't want them to get drunk or anything and drive to Las Vegas or fly to Las Vegas to get married. But they're not a majorly strong bond. So that bond can be broken. That bond can be broken relatively easily. Okay. The second type of bond that we're going to talk about is a covalent bond. Instead of giving up electrons or taking electrons, they're going to share electrons. They're going to share these electrons in order to have their last orbital full and to be happy. So hydrogens have one electron. Two hydrogens, they're not happy because they're missing an electron, so they're going to share. So you usually see them as H2. Same thing with oxygen. They're not happy as individual atoms, but when they share two sets of electrons, then they are happy. And that is a covalent bond, is when they share electrons. It is a stronger bond than ionic bond, so it cannot easily be broken, so I call it the marriage bond. Not that a marriage bond can't be broken, because we know people get divorced, but it is a much stronger bond than an ionic bond. Now the key here is, do they share the electrons equally? Right? Do they share the electrons equally? If the two atoms that are sharing the electrons are the same size, then they're going to share the electron. Okay, they're going to share the electron. Now, write this in your notes. Let me take that out for a second. So when they equally share the electrons, it's called a non-polar covalent bond. A non-polar covalent bond. Because the two oxygens are the same size. The two hydrogens are the same size, so they're sharing it equally. Now, I'll come back to this in a second, but I'm going to tell you a story. So we're going to pretend that either at Lincoln or at VU that we have a sumo wrestling team and we have a gymnastics team, which we have neither. And let's say one of the gymnasts thinks the sumo wrestler is really cute. So she goes up to him and says, "Would you like to go out and share a pizza?" And I want you to think of the pizza as an electron. So he says, "Ugh, yes, I would like to go out for a pizza." So they go out for pizza and they order pizza and they're going to share that pizza. But are they going to share that pizza equally? And the answer to that is probably no. The sumo wrestler, because he's much bigger, is going to eat more of that pizza or carry more of the electron. Remember, the pizza is an electron. The gymnast is going to eat less of the pizza. So this leads us to what's called a polar covalent bond. A polar covalent bond is when they don't share the electron equally. So this is a molecule of water. This is a molecule of water, and because the oxygen, who would be like the sumo wrestler, is much bigger than the gymnast, who's the hydrogen bond, they're sharing an electron, but the electron's going to spend more time around the oxygen because it's bigger. So it gives us a slightly negative charge, Because that negative electron spends more time around the oxygen, the hydrogen is going to have a slightly positive charge. These are not ions because they are sharing an electron. They are sharing an electron, so these are not ions, but this sets up what's called a polar covalent bond. So a polar covalent bond is the unequal sharing of electrons. Water is notorious for this, and because of this polar covalent bond, it leads to, when we're looking for life on other planets, we're looking for water, and I'll show you that. So again, two atoms that are the same size will equally share the electron, and that is a non-polar covalent bond. If they are unequal, in the case here the oxygen is much bigger than the hydrogen, then it will be a polar covalent bond. Okay, the next type of bond we have is not between individual atoms, but between molecules. In this case, and it happens with other molecules, but for a human anatomy and physiology course, we're focused on what happens with water. So hydrogen bonds are weak bonds between hydrogen and oxygen atoms. So because they are polar covalent and the hydrogen has a slightly positive charge and this oxygen has a slightly negative, the water molecules are going to be attracted to each other. It is a weak bond. It is constantly made and then broken and then made then broken, and I'll show you an image of that in a second. These hydrogen bonds, again, are key to life. So when we go to other planets or other moons of planets, we are looking for water because they have these hydrogen bonds, and these hydrogen bonds exist because of the polar covalent bonds, and it leads to having a good chance of finding life on that planet or moon. All right, so you can look at a thing of water while you do this. These are water molecules and they have energy, and these represent, and I'll add a few more just so you can go ooh and ah. They're constantly, if you look at water, it doesn't look like it's doing this, but the water molecules in the water are constantly breaking bonds, breaking these hydrogen bonds and making new ones. So there's energy in water. There's energy in water, and this energy is enough to keep these things moving. Now, if you start to freeze the water, there's less energy, and the bonds will not be broken as much, and it becomes a solid. On the other hand, if you heat the water, then what happens is there's so much energy in that heat that these hydrogen bonds are broken, and that's what steam is. It's water molecules. They've let go of this hydrogen bond between other water molecules. So I'm going to show you what it means to dissolve something, and we'll spend time on this in class. And you have to understand this because this is one of the reasons that water is so key to life. So here's a sodium chloride. Here's a sodium chloride. Okay. You need to think about what kind of bond exists between that sodium chloride. You also then need to think about what type of bond exists between these two water molecules, as well as these two. Okay. So when something dissolves, think about it. You take salt, you put it in water. You see the salt, but then you don't see it. Okay? What happens to it? But yet, if you taste the water, you can taste the salt. So what's going to happen is this bond's going to break, these bonds are going to break, and we're going to dissolve the sodium in the chloride. Now, I'm not going to go into this much more. This is part of the exercise that we'll do in class. I'll expect you to watch this video before you come to class. There may or may not be a quiz, depending on the situation, and then we're going to talk about this, and then we're going to relate this to the use of Gatorade as a supplement when the weather is really hot. Okay, so one thing I want to reiterate, water is necessary for life. These hydrogen bonds between the water molecules is the reason why. These water molecules can drag each other up a tree, so the tallest tree in the world can get water to the top because these hydrogen bonds between water molecules will let that tree kind of suck it up to the top. When water freezes, most things when they freeze become heavy and dense and sink. When water freezes, it floats, and so life underneath that ice can exist. And then another thing that water allows is for things to dissolve. And that's what we will go into in class, and that's what we'll do the case study over Gatorade over. All right, so make sure you understand types of bonds, the basics of what I went over. If you have any questions, make sure you email me or talk to me in class.